So interval notation. So we want to graph the inequality on a number line. Then we use interval notation to describe the shaded regions. Interval notation shows that a value falls between two endpoints or two extremes. So let's talk about this first graph. 1 is less than x and x is less than or equal to 6. So if I were to graph this compound inequality, I would have a low value of 1, open circle. It would go up to 6, closed circle, and I would shade the region in between. So interval notation uses parentheses and brackets. Parentheses means we include the number. Brackets, oh, I'm so sorry. Hang on a second. Hang on. Brackets mean we include the number. Parentheses means we do not include the number. Include, my spelling's off this morning. All right, so in A, this low value of 1, okay, that's our minimum. So the low value of 1, and we do not include it because it's an open circle. And it goes up to 6, and we do include it. Okay, so this would represent that shaded region. Okay, one thing that's important is interval notation is not a coordinate pair. Okay, it's not a coordinate pair. It represents where a value for this solution set could lie. It's going to be somewhere between 1 and 6. It could be 6, but it can't be 1. Okay? What about B? X is bigger than -3. So -3, open circle, shading to the right. All right, so my low end is -3, and I do not include it, so it's a parenthesis. My high end, well, this arrow goes on and on and on and on and on and on for infinity. Okay, so it's the high end, the maximum is infinity, which looks like a sideways 8 sign. And then I never include brackets on infinity. Since infinity is not a number, it's this concept. All right, so -3 to infinity, anything in between those two values represents a solution here. Okay? What about x is less than or equal to 9? So if I draw a number line, I've got 9, closed circle, going off to the left. Well, what's the low end? Well, this arrow is going on and on and on for infinity. So it's not going to be infinity. It's not going to be positive infinity. It's going to be negative infinity. The biggest negative number that you can think. And even more negative than that. That's what the concept of negative infinity is like. All right, so negative infinity, and I do not include it, so it's a parenthesis because it's more of a concept than an actual number. And then my high end is 9, and I do include it, so it's a bracket. Okay? So in interval notation for infinity or negative infinity, only use parentheses. No brackets when you're dealing with infinity. All right? So why do we have this concept of interval notation? Well, it's going to help you out when we're talking about functions. So we can use interval notation to describe the domain and range of a function. So like in A, we have this function, we have arrows, which is indicating that this graph is going on and on and on and on and on forever. So let's find what's the domain, what's the range of this function. So remember, domain represents what are your x values that you can plug in. What are your possible input values? Well, this x-axis goes on and on for infinity. And there is no limit here because these arrows represent this its function is going on for infinity. All right, so I have no limitations on what I can plug in for my x. I could plug in negative 1,000 and I'd get out an input. I could plug in 4 and I would get out an output. All right, so I have no limitations on my domain. So I could plug in anything from negative infinity to infinity. The range, however, is my y's. So if I look at my y-axis, if I look at my y, all right, the low end of this graph is right here. That's the lowest point on my graph. I don't go off to negative infinity. I only go down to negative 3. And I do include negative 3 because there is a point there. Okay? But what's my high end? Well, again, I got those arrows going off to infinity. So anywhere from negative 3 to infinity, that's going to represent a potential output that I could have for this graph. Okay? What about for part B? Domain, possible x values. So I've got the arrow going off here, which means anything from negative infinity up until this point right here. This is where the fun stops. All right, so I'm going to mark this down to here, and I'm just going to count how far over do I go on my x-axis. So 1, 2, 3, 4, 5, 6. Okay? The furthest, the highest x value that I can plug in is 6. And because it's a closed circle, I include the 6, so I have a bracket. All right, so anything from negative infinity to 6, I can plug into this graph. All right? Range, what's the lowest output that we get? Well, the lowest, if I look at the y-axis, the lowest is right here. All right, so that is an output of 0. That's a y-coordinate of 0. And now I see how far up I can go. You may think that we stop there because it's an open circle, but we have to look out for our arrows. Our arrow here represents that this is going to go on forever and ever and ever and ever, all the way up. So the lowest value is 0, but the highest value is going to be positive infinity. Okay, so for domain and range, you're just thinking about what are my possible inputs, my x values, and what are my possible outputs, my y values. And then we use our interval notation to represent that. Okay, so I've got C and D down here. I want you to try these. Pause the video. Try to identify what is your domain, what is your range when it comes to these graphs. All right, you should get those as your answers. Let me know if you have any questions. Thank you for watching. Practice, practice, practice. Practice makes perfect, all right? Have a good one.